Hey, what's up guys? My name is Saurav and this is my YouTube channel Data Science Novice. So if you are new to this channel, please do like and subscribe. Your efforts are massively appreciated. So I'm back with another missing values technique. So if you don't know, this is a lecture series on data pre-processing techniques where we are going to learn how to pre-process data for the machine learning algorithms. So in this series, we are going to understand techniques to treat missing values, variable encoding, outlier detection, etc. And the full information of the course can be found in the first video of this playlist. So if you are new here, I would suggest you to watch the first video where I have explained the roadmap for this course. So today we are going to do the Python implementation of anti imputation, and we have already talked about this technique in the previous video. So if you don't know what this technique is all about, I would suggest you to watch the previous video. So the starting code is going to be very similar to the previous one, so you may feel some repetitiveness. And the link for this notebook is in the description box. And don't forget to follow me on GitHub. I have some amazing repository there, so feel free to check them out. So here I have imported all the libraries. We don't have to import any new library for the imputation because we are going to create our own function. Next, we are getting the data, and again, the link for the dataset is in the description box. In the next block of code, we are running through each variable of the dataset, and then we are using two conditions to filter out the variables. And the first one is whether the data is numeric or not. So this pd.api.type is numeric, gives boolean value. Then we are checking another condition, that is the sum of missing values in that particular column should be greater than 0. And if a variable pass these two conditions, we are just going to append it into a new list. So in nutshell, this block of code is helping us find those continuous variable for which we have some missing values. So now let's check how many variables satisfy this condition. So here we have three such variables, and I'm going to show you for the first variable, and for the rest of them you have to apply it yourself. Now the next important thing that we have to do, and I have seen many people applying the technique before splitting the data, which is wrong because in a way this is a data leakage. So whenever we have to impute values, we have to do it on the training data, or we have to split the data first and then we should go for any kind of data cleaning technique, because this is how things are done and this is considered as a good practice. And here we are using train test split method to split the data into two parts. Next, we are going to check the distribution of the variables, because as we have talked in theory part, we have to use different formula for different distribution. For example, for normal distribution, we have to use different formula, and for the skewed distribution, we have to use different formula. So we are going to plot histogram. So first we are setting the figure size and the style for the graph. Next, we are using subplot functionality. It allows us to plot the distribution side by side. Next, we are using the histplot from the matplot library. Then we are passing a few things like variable name, number of bins, edge color, and color of histogram. And we are just labeling the graphs and setting the title and all that thing. And the same thing is happening with all the other two variables. Notice that in the subplot now, I have changed the number from 131 to 132, which is indicating that this is going to be the second graph. And the rest of the things are going to be very similar to the first variable. So now let's plot this graph. And here we can see that we have three graphs. And from this graph, we observe that the first variable is almost normally distributed, and the second one is right skewed distribution, and the third one is left skewed distribution. So we will see the implementation for the lot frontage variable. As of now, I am going to show you that how to do for normal distribution as well as skewed distribution on the same variable, so that you have no problem implementing other things. So first we are going to create a function by the name of normal boundary, and it will going to calculate the lower and upper bound for the variable. And this function is very simple. So it takes three things. First we have to pass the data, then we have to pass the variable, and finally we have to pass the distance, that whether we want to consider one standard deviation, two standard deviation, or three standard deviation. But in most cases we will pass this value as 3, but you can play around with this value. Next, we are applying the formula that we learned in the theory part, and notice that we don't have to calculate anything because pandas is doing this for us. So the lower bound is mean of the variable, minus the distance, that is 3, multiplied by standard deviation of the variable. And similarly, we are finding the upper bound of the variable by just changing the sign. And finally, this function returns two things. First is lower bound and then the upper bound. So you can see that how easy it is to do things using pandas or numpy. Next, we are creating a function that calculates the lower and upper bound for the skewed variable. And the code is very similar. We are just changing the body of the function. So here first we are calculating the Iqr for the variable. And we are using the formula that we have talked about in the previous video. So using the Iqr, we are calculating the upper bound and the lower bound for the variable. And then this function returns the same thing as the previous one. So as you can see that I have created two separate functions, but if you remember from mean median mode imputation, we used if condition and were able to include all the strategies in one function. You can do the same thing here, just try to explore this thing as well. Next, we are just creating a plotter function that will compare three variables. So idea is we are going to plot variable with missing values, with lower bound as an imputation, and then upper bound as an imputation to see the change in the distribution of the data. And again, the code is quite repetitive, just go through it and you will understand what is happening. Next, we are creating two variables. So with the first variable, we are using Iqr method to calculate the lower bound. So here first we are calling the variable and then we are calling our fill in any method, and inside the method we are passing our Iqr method and the parameter it takes. Then outside it we are using indexing. So 0 means it is going to grab lower bound and 1 means it is going to grab upper bound. Next we are just going to plot these variables. So let's run this cell. Now here you will notice a weird thing. The original variable has only one peak, but after this imputation we see that there are two peaks, which is not a good thing. So if we are applying lower bound, we see a spike on the lower side, and if we apply a upper bound, we see a spike on upper side. So you can see that this technique changes the shape of the data. That's why it is not used with linear regression models. It's generally used with decision trees. So now let's analyze the statistical property of the data. And if you pay attention to the mean of the variable, we see a drastic change. So the original variable has mean of 69, but in lower bound case, it decreases to 61, and in upper bound, it is increasing to 77. Also notice that the standard error has increased in both the cases. Median values has also changed, so you can see that here the technique is changing the data meaning whole together. And if you remember from 3M technique, we were not seeing this much variation in the data. So which solidify the fact that with this variable, we should go with mean median mode technique. Now next thing is that we are going to fill the missing values using normal boundary function. So here we are going to do the same thing exactly. We are going to create two new variables, that is lower ND and upper ND. Then we have the same code. It is just that this time we are calling normal boundary function and then we are passing the arguments. So here I am passing 3, but you can check with 2 or 1. So just play around with this value and also check how it is behaving when we are passing 0. Check whether it's behaving like mean or not. So now let's plot the variable for this case. So here we also see the kind of distribution we saw earlier, but the height of the spikes are not that much. Also, if you notice, the distance between the original spike and the one after imputation has increased. And if you want to reduce it, you can use 2 instead of 3. And as a practice, you should try doing that. So as we reduce from 3 to 2 to 1 to 0, we will see that these spikes are getting merged together. So now let's see how the statistical properties are changing in this case. And here we are noticing the same thing like drastic change in the mean, standard deviation, etc., etc., which again indicates this point that distribution is changing a lot and we should not use this technique for this particular variable. So that's all about this technique, and if you have any doubt or questions, please let me know in the comment section. And by the way, if you are new to the channel, please do like and subscribe and press the bell icon for the future updates. So see you in the next video. Till then, bye, stay safe and wear a mask.